Hello, everyone. I'm very happy to take part in this Bouma conference. And my name is Tian Yang. I'm come from Chengdu University of Technology in the west of China. Today, I will show you something about the Quasi-armored mud class in the deep water gravity deposit. So this is the outline of my presentation. First, I will introduce the scientific question we want to deal with in this work, and then is the background of the research area. And I will describe the characteristics of the Quasi-armored mud class and also as types. And then we'll discuss the implications for the transport processes of the gravity flow, especially focus on the formation of the Hebron even bed and also the massive sandstone. And last is the discussion. So actually, this story is come from the Bouma sequence. Actually, everyone is familiar with this classical Bouma sequence from TA to TE, from the bottom to the up to the top, and also in the proximal fan, we will find some complete Bouma sequence, and while in the distal fan, you will find part of this sequence. Actually, this Bouma sequence can give us some very good information for the transport and the depositional processes of the gravity flow. So actually, the study of the sediment structures, initial phases of initial phases association, and also the depositional sequence phases tracks are all aimed at to interpret the transport and the depositional processes of the gravity flow from the rock record. However, this is not an easy task, as we can see. The controversy of the Bouma sequence have never stopped. Well, in Bouma was interpreted the overall sequence of the deposition of the turbidite current, and Middleton and Hampton in 1973 they interpreted this sand deposit as the turbidite current and the mud deposit as the pelagic or hemipelagic deposit. Well, in 1982, Lower interpreted the TA diversion as the high density turbidite current and TB to TD as the low density turbidite current and the mudstone as the pelagic or the hemipelagic deposit. Well, in 1997, well, Shamgam interpreted the TA diversion as the sandy debris flow deposit and the TB to TD diversion as the bottom current rocking deposit and the mudstone as the pelagic and hemipelagic deposit. So we can get the conclusion that there are many alternative interpretations to for describe the transport and the depositional process from the rock record. So this controversy also delivered to some other phenomena such as the formation mechanism of the massive sandstone, especially the controversy between the sandy debris flow and high density turbidite current. Also, in recent years, the formation mechanism of the Hebron EV bed also have different interpretations, such as the vertical fractionation and also the longitudinal fractionational controversial. So we are wondering whether it is possible for us to find some evidence that can clearly indicate the transport and the deposit process from the sediment record. So we try from the Quasi-armored mud clasts. So this is the research area of our study. The Bouma Basin is located in the north of the South China Sea, and our research area, the Weixinan site, is located in the northwest of this Bouma Basin and bounded by this Weixinan Fault. Well, actually in the Pelagian, this is a typical lacustrine basin, which the basin has experienced initially raft in the Pelagian, and in the later Eocene, in the upper part of the Liusagang formation, the water depths of the basin have experienced its max, and a large amount of sediment was transported from the uplift through the hyperpecular follow to form the subaqueous fans in this basin. So we choose this subaqueous fan near the Weixian uplift towards the research object, and we have a longitude profile to extract the internal structure of the subaqueous fan from the proximal to distal. So this is actually the longitudinal distribution of the gravity flow in the up part of the Liu-Sagang formation. As we can see, well, the cyclists and the green sands, also the net growth of this subaqueous fan are decreased from the proximal to the distal, from the southwest to the northeast. And also we can find a gently progradating stacking pattern from the southwest to the northeast from the vertical stacking of those deposits. So luckily we have two pieces of core from well, WZ1174 and WZ1171, and those cores helped us to further analyze the sediment characteristics of those gravity flow deposits in this lacustrine basin. So this is the polished core from those two wells. Well, the detailed features analysis will not be described in this term. And you can see, well, in the proximal WZ1174, those deposits are mainly dominated by this thick, massive, or normal graded coarse grained sandstone, which are caused by the high density turbidite current. While in the distal WZ117-1, those deposits are mainly dominated by those hybrid even bed with different thicknesses. And the coarse-armored mud classes are mainly located in those hybrid even bed, and especially in the H3 diversion. So why we call this coarse-armored mud class? As you can see, the traditional armored mud balls, those are usually rounded with the pebble or granule and coarse grain sandstone around, and this indicates that the plastic mud is round at the bed of the pebble or the granule or coarse grain sandstone, and finally result in this round shape. Well, on the contrary, those coarse-armored mud clasts, you can see they are usually irregular with isolated granule or the group of granule in this mud clasts, and usually those mud clasts are lofting in the massive sandstone or the argillaceous sandstones. And occasionally, those type 2 coarse-armored mud classes, those group granular may transport to those isolated coarse-armored mud classes as the transport distance increased and the abrasion increased. So then we doubt whether those phenomenon is common or occasionally. So we reviewed many papers in the deep water gravity flow, which focus on the deep water gravity flow, and we finally found that actually those phenomena are quite common, but many authors are just simply attribute those to the armored mud class, armored mud class, a lot of coarse-armored mud class. Well, we have the different opinion. We think those armored mud class, coarse-armored mud class are different with the armored mud balls. First, in the shape, well, the former is irregular mud class, while the mud balls are the round mud balls. Another case is in the location. Well, the former is located in any part of the sequence, while the mud balls are mainly located in the lower part of the sequence, and also the distribution of the outside cores are different. While in the coarse-armored mud classes, there are many granular armored, and while in the armored balls, there are many pebble armored. So meanwhile, the gradual distribution of those coarse-armored mud classes in the hybrid even beds from the lower part to the of the H1 diversion to the upper part of the H3 diversion gave us some further information for the formation and transport of those coarse-armored mud class. And you can see in the lower part of the H1 diverging, you can see some outside granules are injected to the subset merged, which is very likely the breadth of those quasi-armored merged clasts. And here is, you can see those quasi-armored merged clasts are located in the middle part of the H1 diverging. In here, you can see in the H2 diverging of the hybrid even bed, you can see some outside granule in this diverging. And most of these most of those quasi-armored merged clasts are located in the upper part of the H3 diverging. So therefore, according to those distribution of the quasi-armored merged clasts in the hybrid even bed, we try to summarize the schematic model for the formation of the gravity flow with those quasi-armored merged clasts. Firstly, we think those quasi-armored merged clasts are mainly from the erosion from the granular or sandy high-density turbidite current, and those merged clasts will, and those merged clasts will further floating with the transport of those follow and accumulated in the upper part of the follow. So those accumulated of the armored merged classes will increase the strength of the follow and the will transformed into the multi-debris follow, and finally those results exhibit of the happen even bad. So this is actually the overall evolution processes of the gravity follow with the emergence of the armored merged classes. So if this so if this hypothesis is acceptable, so then we can discuss the implications for the transport of the gravity flow. First is about the formation of the hybrid even beds. Well, as I have mentioned before, there was the vertical stratification and the longitude fractionation controversial, and also in the recent BAS has published a paper to indicate that those merged classes are formed by a backset transport model, and also Dowden indicated that those merged classes are from the erosion and transport forward. At least for the hybrid even bed with the quasi-armored merged class, we can see that these agree with the longitude fractionation model and also agree with the Dowden model. Secondly is about the formation of the massive sandstone. Actually, we will know that there are many hypotheses put forward to interpret those massive sandstone, especially for such as the vertical suspension fallout, the transitional craft, the sustained liquid zone, and also the formation from the low cohesive debris follow or poor cohesive debris follow. At least for the massive sandstone with the quasi-armored merged clasts, we think that those are caused by the high density turbidite current. So thus we see those quasi-armored merged classes may therefore provide the important evidence for the longitudinal fractionation model for the hybrid even bed, and also the high density turbidite current model for those massive sandstone. However, the composition and the consolidation of the merged subsets, and also the grain size and the erosion ability of the follow, the formation process of the merged classes are all influenced on the formation of those quasi-armored merged classes. So more case studies are required in order to substantiate to the present hypothesis on a general basis. So this is the overall story. Thank you for your attention. Any questions are welcome. Thank you.
Thank you very much for your presentation, Tian Yang. Some wonderfully detailed observations in there. So while we wait for a question from the audience, my question is about the grain sizes. So the grains that are stuck in the mud clasts in the majority of your examples seem to be larger than the grain size of the surrounding sandy deposit. Did I see this correctly? And what is your explanation of this discrepancy in grain size?
Yeah, you're right. It's bigger than the outside sandstone.
Yeah, and how should we interpret this difference in grain size between the sand stuck in the clasts and the sand surrounding the mud cast?
Yeah, I was interpreted that those high density turbidite current, the erosion, the mud subsides and inside the mud clasts, and then those mud clasts are lofting to the upper part of the follow when it was transported downslope. Then when it deposit, those green signs are bigger than the surrounding sand.
Yeah.
Yeah.
Okay, that makes a lot of sense. Yeah. Thank
Yeah.
you very much for your presentation and your explanation, Jiang.